Hi guys, how's it going? It's Julian and welcome back to my YouTube channel. Today we will be talking about a pretty different topic. It's about machine learning, and the intention of this video is talk and provide you with the most important concepts about machine learning and different resources that you can use to improve your skills if you want to introduce yourself in this field. Of course, my intention with this video is not to provide you with a lot of information and specific information about this. It's more for me and for you, like an introductory video. I will be talking about the main concepts, and I will provide you a couple of tools and a different kind of topics that you can follow to learn about this in a more deep way. And that's it basically. Besides, there are a lot of concepts which are pretty hard, and for sure there are other resources that you can find on YouTube or on internet which could explain these kind of topics in a better way than me. So yeah, the intention of this video is basically an introduction to machine learning, and read a little bit about a particular topics. The first topic, which you can follow in that guide in this website, which I will be putting here below. And yeah, that's it basically. Of course, I don't know too much about mathematics, and here we have a lot of equations, and I'll do my best, but of course are pretty complex, so I won't be provide too much detail about this. For that, you can find different other and amazing YouTubers online. That's it. I don't want to waste too much time in those equations here in this video, because you can spend easily like more than 50 hours studying this, and even though it could be kind of hard become a master in this kind of topics, so it's up to you. Recognize those equations by yourself and study them, and yeah, that's it. So the intention, for sure, I don't know how much will be this video. For I won't read anything about this website, because how I said, it's a long amount of data, and it could be many videos. So just we will make a review about the main concepts, and if I can start to learn this new skill, of course you can do it better than me. So if I can engage you with this topic, it's pretty cool for me. And making this video as well, I can commit it with this topic to learn more about this in the future and become better in this skill. Of course, it's about consistency, because there are many topics and many subjects which can take years to be a master on them, but with consistency you can do it, and at least you can have this kind of resources to practice a little bit each day or whatever you want. That's it. Okay, let's go ahead with this. I have a couple of terms here which are the most important, and for example, the most important concepts when we talk about machine learning, and which we need to have in mind when we read this documentation that I will provide you, are different. We have the main concepts are this: supervised learning, which it's about training a model on a labeled data set, and where the input data is paired with the correct output. This includes regression, predicting continuous values, and classification, predicting categories. As the second one, we have unsupervised learning, algorithms from unlabeled data, finding patterns or intrinsic structures within the data. Clustering and dimensionality reduction are common unsupervised learning techniques. The third one is semi-supervised learning, a blend of supervised and unsupervised learning using both labeled and unlabeled data for training. And the fourth one, it's reinforcement learning. Agents learn to make decisions by interacting with an environment. They receive feedback in form of rewards or penalties and adjust their strategy to maximize rewards. And the last term, and I think is one of the most important and the most popular, I guess, lately, it's neural networks. A network is a network of interconnected nodes, neurons, organized in layers. They can be simple or complex. It depends of the it depends of the project, I guess. Well, this concept sounds kind of abstract, but it's very important because the information in this website that I'll provide you below is called scikit-learn, machine learning in Python. It's very important because we have different main concepts and algorithms and techniques to organize the data. And for example, as I said, in the website that I provide you, we have different tasks and techniques which are related with machine learning, and the most of them are the next ones: classification, regression, clustering, dimensionality reduction, and model selection. I have a friend of mine. She is studying computer science, and she told me that the first three are the most important and the base of the machine learning. Of course, these three are classification, regression, and clustering. Classification basically it is related with sorting objects into predefined categories. Regression is related with predicting continuous values associated with an object, and clustering is related with grouping similar objects automatically. And she told me that these three are the most important and the base of machine learning, so we will stay focused on these three first, and then you have the rest of three more if you want to expand your knowledge eventually. But to start, this is pretty useful, and so she know more about this than me, so I will follow their advice. And okay, let's start with the first one. We will start with classification. Well, a little bit more information about the classification. Well, as I said, is related with sorting objects into predefined categories, and it is used in spam detection, image recognition, and etc. And algorithms include gradient boosting, nearest neighbors, random forest, logistic regression, and a couple of and so on. So, and well, related with classification, we have like a list about the main topics which we will be talking about. There are many topics, and inside those topics we have subtopics, and it's amazing, and it's a lot of information. I won't be able to read the 1% of the knowledge and the information that it is here, but I will provide you the link below. And well, we start talking about supervised learning and unsupervised learning, and those concepts are important because here those topics are organized considering that, for example, we have in the user guide of this classification, we have supervised learning, unsupervised learning as a second topic, model selection and evaluation, inspections, visualizations, dataset transformation, dataset loading utilities, computing with scikit-learn, model persistence, common pitfalls, and recommended practices. to be more precise with these concepts about supervised learning and unsupervised learning, I will explain this in a more deep way. Yeah, I will do that. So basically, supervised learning talk about training a model on a labeled dataset where input data is paired with the correct output. And this includes regression and classification. And when we talk about unsupervised learning, algorithms learn from unlabeled data, finding patterns or intrinsic structures within the data. And in this kind of unsupervised learning, we have clustering and dimensionality reductions are the common unsupervised learning techniques. So yeah, that's it. And that's because those concepts were important at the beginning. So when we talk about supervised learning, we have, first of all, the main topic here, and the first one is linear models. And inside this topic, we have a lot of subtopics. To be precise, we have 18 subtopics, which it is a lot, and the website have a lot of information as well. It have a couple of pictures, which it could be better if I could provide you, but it's like kind of complicated at this moment. Maybe when I grow up, I can prepare better this kind of videos to be more precise and read and show you the equations and the images in real time with all of you. But for now, it's just an introduction, and if you find it useful, I will be pretty happy. But it's all that we need for the moment. And we have like different equations and different stuff here, images showing you how this works. And yeah, a lot of code and a lot of stuff, a lot of maths, a lot of mathematics. Of course, I'm not a mathematician, so I won't waste too much time on that. It's just reading in a superficial way, and then you at least will have the information that you can find there. So yeah, that's it. Okay, linear models. The following are linear models. The following are a set of methods intended for regression in which the target value is expected to be a linear combination of the features. In mathematical notation is y, it is the predicted value. Okay, and we have here an equation. It's not a big deal, to be honest. It's y parenthesis w colon x, we close parentheses, equal w0 plus w1 x1 plus to the infinite, basically the same equation. Across the module, we designate the vector. Across the model, we designate the vector w equal w1 to wp, which represent the infinite, as cov, and w0 is the intercept. To perform classification with generalized linear models, see logistic regression. Okay, here we have ordinary least squares. Ordinary least squares. Linear regression fits a linear model with coefficients w equal w1 to w to infinite. To minimize the residual sum of squares between the observed targets in a dataset and the targets predicted by the linear approximation. Mathematically, it solves a problem of the form. I cannot pronounce this equation, but yeah, it's like if you had mathematics in the high school, it's like we have a x and the y one, and we determine different points in that graphic, and we make a line between those points. Linear regression will take in its fit method arrays x, y, and will store the coefficients W of the linear model of its cove member. I have code here. Okay, I will try to read this because I think it is useful and important. It's like basically we are working here with Anaconda or with Jupyter Collapse to make this with Python. Okay, this is we import the sklearn from the linear model a library. So rec is equal to linear model, the library. Okay, sorry, I made a mistake here. From the library sklearn, import linear model. Rec is equal to linear model dot linear regression. Rec fit, oh well, we have an array and different stuff. It's not pretty important, but basically, let's go ahead with this. The coefficient estimates for ordinary least squares rely on the independence of the features. When features are correlated and the columns of the sign matrix X have an approximately linear dependence, the design matrix becomes close to singular, and as a result, the least squares estimates become highly sensitive to random errors in the observed target, producing a large variance. This situation of multicollinearity can arise, for example, when data are collected without an experimental design. Linear regression example. That's an example that you can see there. We have the non-negative least squares. It is possible to constrain all the coefficients to be non-negative, which may be useful when they represent some physical or naturally non-negative quantities. For example, frequency counts or prices of goods. Linear regression accepts a Boolean positive parameter. Okay, linear regression accepts a Boolean, which it is a positive parameter, when set to true. Non-negative least squares are then applied. Non-negative least squares are then applied. Ordinary least squares complexity. Okay, 1.1.12. Ordinary least squares complexity. The least square solution is computed using the singular value decomposition of X. If X is a matrix of shape and samples and features, this method has a cost of 0 of O parentheses n samples quote 2 features, assuming that n samples is higher, equal or higher than features. Okay, that was kind of okay. Regression. This looks amazing. So I will be reading quickly. This will be the last example, because yeah, it's kind of difficult and you need to pay a lot of attention. I'm starting to have a couple of mistakes with my speaking. It doesn't matter too much actually, but you know what I mean. Okay, 1.1.2 Reich regression and classification. Regression. Reich regression addresses some of the problems of ordinary least squares by imposing a penalty on the size of the coefficients. The Reich coefficients minimize a penalized residual sum of squares. This is a question that I cannot read, to be honest. It's kind of difficult. I need more knowledge about mathematics. But at least I know that now, and I can improve that aspect of my skills to become better. And you need to do it as well, guys. So I will feel proud of you. The complexity parameter a higher equal higher than 0 controls the amount of shrinkage. The larger the value of a, the greater the amount of shrinkage, and thus the coefficient become more robust to collinearity. I have a couple of pictures here, but of course you cannot see it, so sad. As I said, I will try to eventually improve this setup to provide better content for all of you guys. As with other linear models, Reich will take it as with other linear models, Reich will take in its fit method arrays x, y, and will store the coefficients w of the linear model in its cov member. And we have here another piece of code, which is kind of complex at the beginning because it could be better if we just apply this in one interpreter like Jupyter Collapse or Anaconda. It could be better because we can see what is happening and how these kind of algorithms and mathematics it works. So I cannot apply this now, but I recommend you to, meanwhile you're reading this kind of content by yourself and expanding your knowledge, apply this kind of code in one of those stuff to see how it works in a practical way. Note that the class Reich allows for the user to specify. Note that the class Reich allows for the user to specify that the solver be automatically chosen by setting solver equal to auto. When this option is specified, Reich will choose between the LBFGS Cholesky and sparse undercode solvers. Reich will begin checking the conditions shown in the following table from top to bottom. If the condition is true, the corresponding solver is chosen. We have here a table which a lot of technical specifications that I cannot understand yet because as I said, I need to apply it in this kind of interpreters like Anaconda or Jupyter Collapse. Actually, it's pretty interesting, this stuff. I will read a new one because it's pretty interesting, even when it sounds kind of hard. But let's go ahead. 1.12.2, classification. The Reich regressor has a classifier variant, Reich classifier. This classifier first converts binary targets to brackets -1 :1 and we close the brackets, and then treats the problem as a regression task, optimizing the same objective as above. The predicted class corresponds to the sign of the regressor's prediction for The predicted class corresponds to the sign of the regressor's prediction for multi-class classification. Sorry guys, I screw my voice at that moment, but I'm better now. The predicted class corresponds to the sign of the regressor's prediction. For multi-class classification, the problem is treated as multi-output regression, and the predicted class corresponds to the output with the highest value. It might seem questionable to use a penalized least squares loss to fit a classification model instead of the more traditional logistic or Hain losses. However, in practice, all those models can lead to similar cross-validation scores in terms of accuracy or precision recall. While the penalized least squares loss used by the Reich classifier allows for a very different choice of the numerical solvers with distinct computational performance profiles. The Reich classifier can be significantly faster than, for example, the logistic regression, with a high number of classes because it can compute the projection matrix only once. This classifier is sometimes referred to as a least squares support vector machines with a linear kernel. Example of this classification, we have the plot range coefficients as a function of the regularization, classification of text documents using sparse features, and common pitfalls in the interpretation of coefficients of linear models. And basically that's it. It was pretty interesting. It's kind of hard to understand. It could be better. In my case, I prefer to learn the stuff like quickly and then uh, understand a little bit the surface of the topic, and then come back and understand the logic about mathematics and stuff. I prefer to do that in that way. So I don't care too much if I didn't understand pretty well at the beginning. Then you can apply that in a technical way, like in those interpreters like Anaconda or Jupyter Collapse. See how it works, the algorithm, find different resources to ask for more information about how that algorithm works or that equation works, for example, to ChatGPT or stuff. And yeah, you can start to understand in a more practical way, and with these kind of resources you can have pretty good access to good information if you want to make this more deep. But of course, mathematics at the beginning is kind of difficult because it's very abstract concepts. Yeah, it could be hard at the beginning, but I hope you guys find it useful. I hope you have had learned something. Yeah, it was pretty cool for me. I started to learn this stuff. I needed to change a little bit the content of the channel because, uh, um, well, I can explain that in other video. It doesn't matter right now, but I hope you find it useful. I don't know for sure. I won't be creating more videos about this, like reading, is it like in a long term, like a particular section reading each one of these topics which we can find here in this website, because it's a lot of information, it's a lot of data. It's not very comfortable for you and for me because I cannot share the screen right now about my computer. So I hope you at least you can find motivation. If something like me can make this, you can do it as well. And I will hope you can learn something new and interesting for you. And yeah, never is a bad thing. Learn new stuff for your life. So have a good day. I hope you uh, had enjoyed this. See you later, and bye bye.